Hi, my name is John. I'm a Cloud Alliance architect from Check Point. In this video, I'm going to introduce the Azure Gateway Load Balancer and its integration with CloudGuard Network Security. First, we're going to start with an introduction of the Gateway Load Balancer. Then we'll go through the setup process. Lastly, I'm going to run test traffic through the Gateway Load Balancer and show how CloudGuard can protect your application. Gateway Load Balancer is a type of load balancer which enables high performance and high availability scenarios for a network virtual appliance, like a next generation firewall. It allows Azure customers to enable transparent NVA insertion in a network path. Under the hood, the load balancers uses VXLAN tunnel to encapsulate traffic between the load balancers and the security gateway. The first benefit this brings us is now we're able to preserve a source IP address that is accessing your application. This will help security teams to identify threats quickly without having to correlate both firewall and application logs. It will also help application owners to get more metadata of its users that are using the application. Other benefit is simplifying cloud security architecture. Because the Gateway Load Balancers uses VXLAN encapsulation, we're able to do away the complex routing by redirecting traffic from our existing external load balancer to the Gateway Load Balancer for inspection. This will minimize complex routing and keeping traffic symmetrical. Gateway Load Balancer also makes it very easy to add and remove security inspection. You can do this from an API call or directly from the portal. It also supports cross-subscriptions, tenant, and regions. With the new Gateway Load Balancer, it's now even easier and more flexible to protect your applications with CloudGuard Network Security. This is our lab diagram. I've already deployed a web server behind an external load balancer. This will represent your existing application. We will use an ARM template to deploy our Gateway Load Balancer with a VMSS cluster behind it. At the time of this video, Gateway Load Balancer is in public preview. I want to highlight few items before we start. At this time, we support CloudGuard version R81.10 or later. While in preview, our ARM template is in GitHub instead of the marketplace. Once the solution goes GA, we will have the template in our marketplace along with our existing solutions. Lastly, there is no east-west traffic inspection. That means no VNet to VNet traffic inspection unless the workload has a public IP or behind an external load balancer. As a prerequisite, you need to first create an Azure Service Principal. We'll use this service principal to help us deploy our VMSS cluster. This is the same process as you would when deploying our existing VMSS cluster solution. In the lab, we'll create a security VNet, Gateway Load Balancer, R81.10 VMSS cluster with threat prevention blaze enable. I'll also show you a few examples of how CloudGuard Network Security can protect your application. Okay, so to start our configuration, we're going to go to portal.azure.com and then we're going to click on Create Resource. From here, type in Checkpoint. We'll select CloudGuard Network Security, select the CloudGuard Gateway Load Balancer, and we'll go through the interview process. So we're going to put in a resource group, the name of the skill set, our gateway passwords, and here we're going to put in the management server, the name of the management server in the template we're going to be using, and then this is our template name, admin's email address, and in this case here we're going to be managing this VMSS instance using its public IP address because our management server is on the internet. If your server is internal to the VMSS cluster, you choose internal. Here we just put in our SIG key, confirming the SIG key, and we'll leave everything else default here and go to networking. Here we're going to create a new VNet, and the address range we're going to be using 10.253. Define that for the front net. 0. Okay. Looks good. and it will validate the config. Looks good. We go ahead and create. This will take a minute to complete. In the background, the template will go ahead and create the gateway load balancer. It will create our new VMSS cluster. And after that, we're going to go ahead and configure our CME to onboard this to our management station. Now, once we finish the gateway load balancer and the VMSS cluster deployment, we'll then follow the same process as we would on how to deploy the VMSS cluster with Checkpoint. So we'll enter these two commands in our management station. It'll take a couple minutes to automatically onboard the gateways. So as you can see here, once it finishes, it automatically onboard the two gateways that it deployed from the template with all these security blades enabled here. Okay, so next we can go ahead and configure the security policy. As you can see here, rule number 1 and 2, these are created automatically by the gateway load balancer deployment. Please don't modify these rules. They are for the gateway load balancer and the gateway communication. I'm going to fast forward the policy creation. What I'm building is just a simple inbound and outbound rule. Now, CloudGuard has this really cool feature that allows our security policy to be as dynamic as your cloud configuration. This is an external load balancer object from Azure. This object updates itself every 30 seconds. As you add and remove IP addresses from your load balancer, it also updates your firewall rules too. This is a huge time saver and also maintains your security posture as well. Next, we're going to configure CloudGuard Threat Prevention Policy. This will help protect against both known and unknown attacks. We made it super easy to configure in R81. This took me less than 30 seconds to configure. Remember, a firewall alone is not enough to protect against modern attacks. We need multi-layer defenses. The more security layers that you have enabled, the better protected you are. I'll show you some examples in a minute. Now, to configure the gateway load balancer, we're going to go to preview.portal.azure.com and then click on the load balancer. And this is the load balancer that was provisioned previously that is already hosting services. So as you can see, we have our backend pool, and I only have one server running for testing purposes. And then we have our public IP address. Click on that. And then you see there is a field for gateway load balancer, and this is the gateway load balancer that we provision. Click on save, and what this will do is redirect all the incoming traffic to the gateway load balancer for inspection. Next is outbound rules. This is actually for the outbound rule to redirect the traffic to the gateway load balancer or the CloudGuard Network Security Gateway for inspection. We'll select the public IP address, the front-end IP, all the TCP services, right, the backend pool that we'll be protecting. And for the port allocation, we're going to use the default number. Click on Add. Now that we have both the inbound and outbound rules configured, and I'll show you that, in our gateway load balancer object, we can detect the front-end IP address of .111. We have our load balancing rule. Anything to 111 on port 80, we'll send it to the backend pool. So here we can access the .111 Apache server that's running on my Ubuntu instance. In the checkpoint logs, you see that we can see that traffic is being redirected to the CloudGuard Network Security for inspection from the gateway load balancer. Here I want to show you two examples of attacks. One is anti-bot. So this will simulate from the this will simulate the if one of your workload is compromised and it's trying to call home to a command and control server, our anti-bot blade would block this connectivity. And this command will simulate that connectivity. As you can see here, it failed to connect. Next, we're going to download a sample virus file. This is also a good example to show you that how the CloudGuard Network Security is able to block some of the known attacks, so known viruses from entering your network. show you in the checkpoint logs what that looks like. I just simply filter anything that's not firewall. Right, there it is. So the second line here, this is from our anti-bot blade. This is something that was blocked from accessing to the known CNC server. So in case your server has been compromised, the attacker will never be able to control your server, even though it's compromised with malware. This is the example of content protection, right? So this is the virus file, the test virus file that I was trying to download. It was also prevented from getting downloaded. The next few log entries are from our IPS blade. IPS will protect you against known exploits. If your Apache server is vulnerable, it will be protected, giving you time to properly test and patch your servers without getting compromised. Lastly, these outbound rules will help you enforce your security policy and stop the data exfiltration. Any firewall will give you network segmentation, but with CloudGuard Network Security, you get multi-layer protection and also let you define those zero trust assume breach policies at the network level. I hope this video was helpful, and if you find the Gateway Load Balancer solution interesting, please give it a try. We'd love to get your feedback. Here are some useful links to get started. Thank you.